What is going on, wonderful people? It's Medicosis Perfectionalis and welcome back to my statistics playlist. In previous videos, we had an introduction to statistics. We talked about the measures of central tendency, the mean, the median, and the mode. We talked about the range. We talked about the difference between dependent variables and independent variables, numerical variables versus categorical variables, i.e. quantitative versus qualitative variables. Today we shall talk about different ways to visualize data, as well as the advantages and the disadvantages of each of the following: the bar chart, the line chart, the pie chart, the scatter plot, the histogram, heat maps, and tree maps. Click the like button, click the subscribe button, and let's get started. This is my statistics playlist. Please watch these videos in order for maximum understanding and retention. We need to review a topic from a previous video, which is the types of variables in statistics. We have quantitative variables and qualitative variables. The quantitative variables are also known as numerical, whereas the qualitative variables are categorical. Numerical variables deal with numbers, and numbers always have a natural sequence. There is 1, then 2, then 3, then 4, then 5, then 6, etc. But when it comes to categories, they do not necessarily follow one another. Someone is born in Egypt, another in Sudan, a third in Algeria. These are separate categories, so we call these categorical variables. Today we'll talk about the bar chart, line chart, pie chart, the scatter plot, the histogram, the heat maps, and the tree maps, not to be confused with tree diagrams. One has nothing to do with the other. Starting with number 1, the bar chart. What type of variables are we talking about? We're talking categorical variables, which means categories, not numbers. For example, here's the first category, milk, and here's the second category, orange juice. And then let's say that a company sells milk and sells orange juice. At the end of the month, they want to see how many packages or bottles or units of milk that were sold versus how many units of orange juice were sold. So we create a bar chart like this. How many milk? Well, 5 units. How about orange juice? 7 units. But be careful, you have to read the scale. The scale tells you that each unit corresponds to 1,000 cartons. So this company sold 5,000 cartons of milk and 7,000 cartons of orange juice. There is another way that the scale could be written. You go to the vertical axis, which is the y-axis, and underneath the number of units, you're going to say number of unit multiplied by 10 raised to the third power, which means every unit corresponds to 1,000 cartons, just like this. So now this is not a 5. This is 5 multiplied by 10 raised to the third power, or 5,000. And this is not 7. This is 7 multiplied by 10 raised to the third power, or 7,000. Again, milk versus orange juice are categories. Categorical variables, not numerical variables. Qualitative, not quantitative. If you wish to see more videos like this in the future, please drop your favorite math emoji in the comments. So the bar chart, what are the pros and what are the cons? The pros, it's very simple. It highlights the differences, in this case the differences between milk and orange juice, and it's usable in different data types. We can use them for nominal data, just like milk versus orange juice. We can also use them for ordinal categorical data, such as what? Such as 3 levels of chess players. Level 1, the novice. Level 2, intermediate. Level 3, advanced. These are categorical variables, but they are not nominal, as in milk versus orange juice. They are ordinal. Why are they ordinal? Because they have an order. There is a novice, followed by intermediate, followed by advanced, in this order. So they are ordinal. What are the disadvantages of the bar chart? It's not very good at showing trends over time. For example, we sold 5,000 cartons of milk last month, but we do not know whether the sales of milk peaked in the beginning of the month or towards the end of the month, or whether it was the same throughout the month. We have no clue. Next, a bar chart is not very good for large data sets. For example, there are 500 companies in the S&P 500 index in the United States. Trying to plot 500 companies in a bar chart is crazy. And do not get me started on that Russell 1000 index. Plotting 1000 companies on a bar chart is even crazier. Next, if you increase the number of categories, it becomes difficult to compare them effectively using the bar chart. Next, the line chart. Here's the horizontal axis, which is the year, and here's the vertical axis, which is the stock price. This line, hence line chart, is going to show us the price of Apple Incorporated, ticker symbol AAPL, over the last 5 years. Can we see the trend here? Yes, it's trending upwards. Thank you, line chart. So line charts can show us trends over time. They are good at identifying patterns and trends over time. Whether we're going up, we're going down, we were flat, we started low but we ended high, or whatever. Next, you can compare multiple groups or series. For example, we can compare Apple against Google against Microsoft on one graph using 3 separate lines, one line for each company. So you get a line, and you get a line, and you get a line. Disadvantages of the line chart: it can get cluttered very quickly. It's good for numbers, but it's not so good for categories. And because there are no solutions in life, only trade-offs, line charts will show you the trend over time, but they will sacrifice individual data points. For instance, in the previous example, which was the stock price of Apple, using that graph alone, it's very hard to tell me precisely what was the stock price of Apple on the 12th of November of 2022. If you wish to download these doozy colorful notes, go to medicosisperfectionalis.com. I help you learn, understand, and pass exams. If you want me to personally tutor you, reach out to me on my website. The third method of data visualization is the pie chart, which looks like a pie. Here we're talking about the different types of stroke. Doctors have gathered data from many patients who suffered from a stroke, and they found out that about 85% of patients, if not more, had ischemic stroke, and about 15% had hemorrhagic stroke. Ischemic strokes are caused by occlusion, whereas hemorrhagic strokes are caused by bleeding. Please refer to my neurology playlist to learn more. So, any young lad can look at this pie chart and say, you know what? It's safe to say that ischemic strokes are more common than hemorrhagic strokes. Thank you, Captain Genius. What are the problems with pie charts? Many problems. Number one, they cannot show you trends. So it could be that ischemic strokes are more common in the first half of the year and hemorrhagics are more common in the second half of the year, hypothetically. But there is no way you can say this just from this pie chart. Moreover, if we have many categories, well, the pies get really small and it becomes very difficult to tell the difference between this compartment and that compartment. They all look the same. Another disadvantage of the pie chart is that had I not told you that ischemic strokes are 85% and hemorrhagic are 15%, it is very hard to tell just by looking at the pie chart that this is 85% and this is 15%. Even to the experienced eye, it is difficult, unless you have a protractor or something. But let's be honest, when was the last time you even saw a protractor? Pie chart, pros and cons. Advantages: good at proportions. For example, ischemic strokes are way more likely than hemorrhagic strokes, and they are visually appealing. And that's why they use them a lot, ad nauseum, at these useless, pointless corporate meetings. Because most of these corporate scumburgers cannot reckon math at high levels. That's why you have to make it visually appealing for the young kids. Sales, bro. Disadvantages to the pie chart: not good for comparing values across categories. For example, ischemic strokes have many subtypes, but you cannot know that from the pie chart. It gets really dicey when you try to distinguish small slices. Next, the scatter plot. Oh, look at these individual points scattered across the graph. How about these points? Also scattered. How about these? Scattered as well. Oh, points scattered. Scattered plot. Now let's call this graph A, graph B, and graph C. Which of them has a positive correlation? Which of them represents a negative correlation? And which one represents no correlation between the x and the y-axis? Please pause the video and tell me the answer. And here's the answer. For graph A, there is a positive correlation between the x-axis and the y-axis. The more x goes up, the more y goes up. It's like F around and find out. The more you F around, the more you find out. They are positively correlated. And I've told you in the previous video that the component on the x-axis is the independent variable, whereas the component on the y-axis is the dependent variable, because finding out is dependent upon effing around. Next, graph B represents a negative correlation between x and y. As x goes up, y goes down. How about C? No correlation between x and y, which reminds me of third-degree heart block. If you know, you know. If you don't know, refer to my cardiology playlist. Next, the Pearson's correlation coefficient. When the line is straight and going up like this, positive correlation, the Pearson correlation coefficient is roughly around +1. How about this? Oh, that's -1 for the negative correlation. How about this nonsense? It's about 0, nothing. Positive correlation, negative correlation, no correlation. The scatter plot, pros and cons. The advantages of a scatter plot, it can show you two variables. We have the independent variables on the horizontal axis and the dependent variable on the vertical axis. F around, find out. Independent, dependent. Disadvantages of using scatter plots, they are not good for very large data sets. And even if there is a correlation between alcohol use and bronchogenic carcinoma in the lungs, even if the correlation is positive like this, that doesn't necessarily mean that the alcohol caused the cancer. It could be the fact that people who drink too much alcohol also smoke too many cigarettes, and the cigarettes, not the alcohol, that cause the lung cancer. Rule number 1 in statistics is that correlation is not the same as causation. Rule number 2, please refer back to rule number 1. Next, the histogram. Alright, histogram looks beautiful, but hey, how's this different from the bar chart? I am so glad you asked. Note that in the bar chart there is a separation, there is a gap between one category and another. That's why we use the bar chart for categorical variables. Separate groups, not continuous or numerical groups. Now look at the histogram. Look at it. Now respect it. Do you see any gap between the bars? No, there is no gap. Alright, therefore what? This is a histogram, not a bar chart. And you know why there is no gap? Because these are continuous data. These are numbers. And numbers have an order. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, etc. They are continuous. They are not separate categories as in milk versus orange juice. Now you're thinking. The number of people that do not know the difference between the bar chart and the histogram is breathtaking. Every day I say the educational system cannot disappoint me any further, but I get proven wrong every single day. Have you seen our people on LinkedIn? People in real life are changing into tokens and NPCs, and they are proud of it. And no one seems to care. They are driving their car faster and faster into the ditch while cheering themselves on. Also, while we're at it, follow me on LinkedIn. In the histogram, here is the points scored on the exam. So how many students scored between 0 and 10? Only one student. How about between 10 points and 20 points? 2 students did this. Between 20 and 30, also 2 students. Between 30 and 40, 2 more students. Between 40 to 50, we have 3 students. Between 50 to 60, we have a whopping 4 students. Between 60 to 70, 2 again. Between 70 and 80, we have about 5 students. Meaning for this class, the exam was more easy than not. Histogram pros and cons. The pros, the data distribution and frequency are shown and they are beautiful. We know exactly the number of students who scored in each group of points on the exam. Histograms are good for continuous numerical data, whereas bar charts are good for categorical data. Next, heat maps. This is a map of the United States. Since this country exists in the northern hemisphere, as we go closer to the equator, it gets warmer and warmer and warmer. Shocking, isn't it? And as you get farther away from the equator, it gets colder and colder and colder. The heat map will show you which areas are warm and which areas are cold. But wait, there is more. There are gradations of warmth. For example, the dark red is very warm or very hot, whereas the light pink is not as hot. Similarly, the dark blue is very cold. Light blue is cold, but not as much. This is a heat map. Heat maps, advantages, multi-dimensional data, meaning not just cold versus warm, because that will be bi-dimensional, but cold, colder, and the coldest. Warm, warmer, and the warmest. They are good for large data sets, and they are color-coded. You see the high values and the low values. Not just high, but high, higher, highest, and low, lower, and the lowest. Disadvantages of heat maps, they are not so good with too many variables. For example, in the previous map, we only had 12 colors. Imagine what will happen if you try to do a heat map with 200 colors. It will be crazy. Are heat maps only for temperature? No, you can use them for anything you want. For example, here is politics. Blue areas voted for the Democratic Party, whereas red areas voted for the Republican Party. But that's not all. There is blue, there is darker blue, and even darker blue. The darker the blue, the more people voted Democrat than not, and the darker the red, the more people voted Republican than not. Next, tree maps, not to be confused with tree diagrams. Tree diagrams are used in probability mathematics and more, but today we're talking about tree maps as a method of data visualization. This is the stock market in the United States. Of course, it cannot show all the companies in the US stock market, for those are more than 4,000. These are just the biggest companies. Look for the borders, okay? So this is a compartment, and this is a separate compartment. This is a third compartment, a fourth compartment, a fifth compartment, etc. These are technology services. These are electronic technologies. These are financial companies. These are retailers. These are consumer products. These are consumer services. These are utilities. These are energy material. These are health services. These are communication companies. You get the idea. Now, why does Microsoft occupy a bigger rectangle than IBM, for example? Because Microsoft has a bigger market capitalization when you compare to IBM. What the hell is market capitalization? It's the price per share multiplied by the number of shares outstanding. Why is the compartment for Berkshire Hathaway bigger than the compartment for Wells freaking Fargo? Because Berkshire is bigger. Which reminds me of what Will Durant, the late famous historian and philosopher, when he said, quote, "History reports that the men who can manage men manage the men who can manage only things, and the men who can manage money manage all." But I disagree with the late gentle philosopher. And here is why. Warren Buffett's first wife died from oral cancer. See my oncology playlist. Jamie French Toast Dimon developed aortic dissection. See my cardiology playlist. Apple's famous CEO Steve Jobs developed liver failure and required a liver transplant. And Jeff Bezos's high testosterone gave him a competitive edge, but also led him to develop male pattern baldness. See my reproductive system playlist. And Bill Gates's former wife, Melinda French, broke his heart and filed for a divorce. See my psychology playlist. So no, Belly, money doesn't rule the world. Pathology does. Write that down. Also refer to my pathology playlist. So what are the pros and cons of tree maps? The pros. Data in hierarchies are represented. There are the biggest companies, and then big companies, and then small companies, smaller companies, the smallest companies, etc. And very good for size comparison, as we have seen. What are the disadvantages? Not good with too many levels. For example, I have showed you a comparison of companies based on market capitalization, which is valuation, bro, which is not the same as profits. So you cannot see profits and market capitalization and losses and free cash flow and liabilities and assets in the same tree map. You cannot have too many levels. It gets crazy. So let's summarize. Bar charts are simple and they are used for categorical data. Line charts will show us trends over time. They are good for numbers or numerical data, not so good for categorical data. If you want to see proportions, use pie charts, but they are too simplistic and sometimes misleading. The scatter plot will show you an independent variable and a dependent variable, F around and find out. But please remember, just because two variables are correlated doesn't necessarily mean that one of them caused the other. Histograms are robust for numerical data, but they suck at categorical data. Heat maps, colors. There is cool, there is cooler, there is the coolest. Warm, warmer, and the warmest. Tree maps are very good for data in hierarchies, and they are good for size comparison. Learn more in my statistics playlist. And let's answer the question of a previous video. Smoking cigarettes, lung cancer. Which of them is the independent variable and which one is the dependent variable? Remember, we have cause and effect. The cause is the independent variable. So the independent variable here is cigarette smoking. What is the dependent variable? The lung cancer. Why is this? Because the lung cancer is dependent upon the fact that you smoked your lungs out for years and years and years. Of course, this is not true for every single type of lung cancer, but you get the point. You can learn more about lung cancer in my pulmonology playlist. In this playlist, there is a video titled Independent versus Dependent Variable, and there is another video that will teach you about numerical versus categorical variables, continuous, discrete, nominal, and ordinal. And now on to today's question. Let's go to the movie theater, and we're going to observe how many people are going to enter into the movies, and then we're going to have someone count how many males versus how many females went to the movies. Then we're gonna use one of those methods of data visualization to show us the number or the percentage of men versus women who went to the movies. The question is, which method of data visualization should we use? You can choose more than one. Should we use the bar chart, the line chart, the pie chart, the histogram, the scatter plot, the heat map, or the tree map? Which of them can be used? Let me know your answer in the comments. If you value what I do, help me make more videos by supporting the channel. Go to buymeacoffee.com/medicosis. You gotta help your brother out because medicosis is one of the men who can manage only things. I do not manage other men because other men are gross. There are more than 700 premium videos available on this channel. When you click the join button and choose the highest tier, please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine, chemistry, math, and physics make perfect sense.